Sig Figs is short term for significant figures. Which is also known as significant digits. And what it refers to is reporting values and reporting values that are calculated that are meaningful, that the number of digits is meaningful for what you know. So we're going to cover two aspects of Sig Figs. The first is making measurements using Sig Figs, and the second is preserving those Sig Figs when you do calculations. First of all, when you make measurements, you're generally doing one of two kinds. You are either doing measurements where you have a digital readout, such as these two balances shown that have different values on them. And when you have digital readings, you always record all of the digits shown because they are all meaningful. In other words, this balance that shows 4.20 grams, that means we know the value to that many digits, 4.20. Don't leave the zero off. It is significant. And of course, if all the values are non-zero, you report them all anyway. But you don't put extra digits, you don't put extra zeros on the end because the balance doesn't weigh to those digits. When you do readings that are using tick marks, you have to read something like a thermometer, or in this case a pressure gauge. You're going to read to the tick mark, and then you're going to add one more digit that you estimate. So you estimate one more digit beyond the marks. For example, on this thermometer, you can see that the red is between 87 and 88. So we know it's 87 something, and we can estimate about how far it is between the two of those. You might say that's 87.5. The 5 is our estimate of the last digit, and we put that in there because we can see it's not right on 87. That would be 87.0. It's not right on 88. That would be 88.0. Instead, it's about halfway between. If we look at this pressure gauge, we can see that the mark is between 60 and 65. If you count the marks, you'll see that each of them is 5 psi. So we can see it's between 60 and 65. We estimate that it is 64. And the units are psi. So you know it's 60, between 60 and 65. You estimate that it's 64. So that's how you do readings for digital and tick marks. Here's try this for you. Look at the gauge and what value should you record for that. What you should see is that it's between 85, okay, this mark is 85, and the next mark is 90, and it is between those two. You can estimate what it is. I would say it's about 88. And that's the value you should record. Now the second part of Sig Figs is how do you preserve the Sig Figs when you calculate using those measurements. And it turns out it's different for adding and subtracting versus multiplying and dividing, so we'll cover them separately. If you are adding or subtracting numbers, the general rule is to use the digits place. Okay, and I'll show you what I mean. If we have a temperature, such as 87.4 degrees C, or if we have any value, we might want to subtract that from an initial temperature. So let's say we have a final temperature of 87.4. We want to subtract from our initial temperature to get the net change in temperature. Okay, so that's a subtraction problem. We go by place. Notice that we have this first number is good to the tenths place, the second number is good to the tenths place, therefore your answer is also going to be good to the tenths. So we do the subtraction, we get 34.3 degrees C, and we keep all of those digits because we're good to the 10th place, 1 decimal place. So we don't report 34, okay, not 34, not 34.30, because we don't have that place. Okay, so neither of those. Okay, but what if they don't have the same place? Like, let's say we were doing 87.4 degrees C, and let's say our initial measurement was only done to the nearest degree. Let's say we had 53. We wanted to subtract from it. Well, we do the subtraction again. But this time we realize that one of the numbers we know to the 10th place, but the other number we only know to the 1's place. Okay, so we can't do our answer to the 10th place because we don't know what that value is for the other number. So we can only do it to the nearest 1's place. So we have to round this one to 34 for the answer. So once again, with adding and subtracting, go by the place, and whatever place they're all good to is the place you have to use for your answer. It's different when you multiply and divide numbers. There you use the number of digits. Okay, not the place they're in, like in adding and subtracting, but how many digits there are. I will show you what I mean. Let's say we're doing a measurement of density. And we have to do a calculation where we have a mass over a volume. Okay, so you look at those two, you do the division, and you put it in your calculator. You're going to get 1.1428571429 grams per milliliter. It would be ridiculous to record all those digits. We don't know our answer to that many digits. That's why we have Sig Fig rules. But we look at the top number, and that has 2 digits. So we'll say 2 Sig Figs. We look at the bottom number, it has 2 Sig Figs. Therefore, using the number of digits, our answer will also have 2 Sig Figs. Doesn't matter what place they're in for multiplying and dividing, it matters how many there are. So we're going to cut off our number after two digits and report 0.14 grams per milliliter, which is a much more reasonable answer than writing all those digits. Alright, but what if the next digit after your rounding point is 5 or greater? Then we're going to need to round it differently. So for example, if we were doing a multiplication, okay, so our last example was a division. This is a multiplication. Let's say we're doing 2.3 times 14.223. Okay, we plug it in our calculator, and the calculator will spit out more digits than you need. But then you analyze how many Sig Figs there are because we're doing multiplication. 2.3 is 2 digits. And 14.223 is a total of 5 digits. So your answer is going to use whatever has the fewest. We're going to use 2. Alright, so we take our answer, we draw a dotted line after 2 digits, but then we notice the next one is 7, which is 5 or greater. So we're going to need to round up when we report 2 digits. So we're actually going to report that as 33 for the answer. Alright, so try this to see if you understand the rules. The first example has a multiplication and division, so use the rules for that. And I've already done the calculation for you. Okay, so there's a long number of it in there. You decide how it's going to be rounded. The second example is an addition, so it follows different rules, and you decide how you're going to report these answers and round them correctly. Okay, so we're going to analyze this first one. It's all multiplication and division, so we go by the number of digits. 0.34 is 2 digits. 12.47 is 4 digits. And the bottom, 1.7703, is 5 digits. So our answer can only have 2. Whatever has the fewest, our answer will only have 2, which means we cut off the number after 2, but we always look to the next digit and see if we should round our digit up or not. In this case, we need to round up because it's a 9, so it's going to be 2.4 is going to be our answer. In B, we're doing addition. We look at places. Okay, in this first number, we have 2 places after the decimal point, and in this second number, we have 4 places. So our answer will have 2 places after the decimal. It doesn't affect how many total digits we have, just how many are after the decimal. So we go to our number, we go 2 after the decimal point, cut it off, look at the next digit, it's a 4, so we don't round up, we keep it at 182.23 for our answer.